Hey there, Python trainer Reuven Lerner here, and today I want to talk to you about exceptions in Python. Exceptions are a topic that I think deserve a little more love and that people tend to misunderstand. They think that, oh no, it's horrible, it's a crash, when actually it's a way for us to identify when something unusual has happened and for us to trap it. So if I say here x equals, or let's do my list equals 10, 20, 30, and then I'm going to say x equals my list of 999. So here I've created a list of 3 elements. Indexes 0, 1, and 2. And here I'm asking for an item at an index that does not exist. So what should Python do? Let's think about it. One possibility would be to return none. Yeah, but then x is going to be none, and then what do I do with it? What, I'm going to try to print it? I'm going to try to calculate with it? Or I could really get myself into trouble treating it as a value. Another thing is that our program could completely and utterly just crash. And indeed, when people see exceptions, they often talk about the program crashing. But programming language people are like, no, 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 that's not a crash at all. It's an unhandled exception. Okay, well, what does that mean? Well, Python has decided to do what many, many modern languages do. And here in the case of our assignment, always the right side executes before the left side. So if I say x equals my list of 999, the first thing Python tries to do is get index 999 from my list, which does not exist. And that retrieval raises an exception. And indeed, we can see here we get an index error. The list index is out of range. Well, we knew that, right? But there's no way for us to know that in advance. And so basically, what is going on here? Python is saying, hey, something unusual is going on here. You should pay attention and you should try to do something about it. But we didn't do anything about it. We didn't trap it in any way. And so the program stopped. Could we say that the program crashed? Again, we could sort of colloquially say that. But typically people in the programming world would say, no, 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 we had an unhandled exception. No one took care of this exception. No one paid attention to the fact that this unusual event was happening and sort of, dealt with it. And so it was undealt with, and thus we had to stop. Now, I'll add that if you were running this program, this teensy-weensy little program inside of a regular Python program, then the program would stop. Again, it would be an unhandled exception. We can call it a crash, but it's not really a crash. Inside of the Jupyter Notebook, as I'm using here, Jupyter actually traps all exceptions that we don't do with otherwise, and so it keeps me inside of Jupyter, keeps Python running. So it's like a second layer of safety net here. But we're gonna sort of assume that you understand that if I were to run these 2 lines of code in an actual program, well, the program would stop and we would see this index error. So how can I deal with this? How can I make my program more robust? Well, I can say here, let's put it inside of here, try. And try means if there's an exception inside of this block, immediately jump to the except block. Well, okay, I can say now except. And then if there's an exception raised inside of the try block, so execution continues here. And I can say here print, actually, nothing went wrong. We will ignore it this time. Not a good solution. There are many, many problems with what I just did, but we're going to fix those little by little. So what happens now? Well, I run this code, and we execute line 1, we execute line 3, for the try block just sort of puts it in context, and then we execute this, x equals my list of 999, and immediately, because of the exception, we jump to the except block. Now we can make this a little more sort of interesting and a little easier to understand. If I say here, print A, and then print B, and then print C, and then print D, and then print E, and then print F. Now notice what gets printed. Well, A, because it's the start of the code, and then B, and then we encounter our problematic line, and immediately we jump. So this line here, line C, will never be executed in this code. And when we jump to the except block, then we go to D, print, E, and then we exit from the except block and we continue on our merry way. And that's the kind of amazing thing about exceptions, that we can trap them, do something based on that trapping, do something based on, well, whatever we trapped, and then we continue. Now, what if there was no exception? What if there were no exception? Then I can just say here, watch this, x equals my list of 1. And now we get A, B, C, and F. So you see, we got A, we got B, everything runs here normally. There was no exception, so the entire try block ran, and we ignored the except block completely. Now, I mentioned before already that this is not the right way to write try and except. And what's wrong with it? Well, I'm going to get rid of all these prints here. What's wrong with it? Well, the main thing that's wrong is this is going to trap every single possible exception that Python could raise. And that's typically not a good way to go about things. You want to trap the exceptions that you know how to handle, for which you have a plan. And so I want to say here, except. And I'm going to say, except which kind of exception do I want to trap? Well, I know what to do if there's an index error. I'm going to say, except index error as E. And what does that mean? It means only trap index error and assign that error, that exception object to the variable E. And then I can be a little less glib. I can say here, there was an index problem. And watch this. Then I can put this in E in an F string. And so when we print E, we get the message that was, that was part of the exception. And so now if I run this, it says there's an index problem, list index out of range. So we printed what the problem was from our perspective. We printed the problem from the exception object's perspective, and then we continued along. So this is a much, much better way to do things. And indeed, you can see then, if I had a different kind of error, x equals, let's call it 10 divided by 0. Well, what's that going to do? That's going to raise a zero division error. Is that an index error? No, it is not. And thus, we're going to end up with, once again, an unhandled exception. The exception that we didn't trap in any sort of way. Now, so can I add a trap for that? Of course I can. I can have a second except clause. You could actually trap both of them in the same except clause, but I'm going to do it separately. Except zero division error as E. And we say print, avoid dividing by 0. Right? That's always good advice, yeah? So now if I run, it's going to say avoid dividing by 0. There was division by 0 here. So you can have as many except clauses as you want, each of which handles a different type of exception. And again, you can have multiple exceptions in the same clause, although I've seen that less often, I'd say. So this is how we can trap exceptions. Now again, why is this better than getting back none, getting back -1, getting back 0? Well, it's better because exceptions are a completely separate, distinct communications channel within the program. We can't confuse the exception with the original value. And indeed, if I now say, what is x? After all these runs of what I did, what is x going to be? Oh, x is going to be 20 because we got it back from there. But if I say del x, I'm going to delete x, then I'm going to run all this. And now I'm going to say print x. Actually, x is not defined. So in this particular case, x was not defined because first we execute the stuff on the right, and only after we get a value back do we assign it to the variable on the left. If this raised an exception, then we never got to that assignment, and so we can't be confused, right? We're not going to get a value back from a function that is bad. Rather, we're going to get an exception which goes to this incredibly different communications path. It's sort of like if we're having a conversation face-to-face, and my cell phone rings. Well, I'm sorry to say this, but you're not as good of a friend as whoever is calling my cell phone, including like the random spammer who keeps bothering me. So I'm going to say, hold on a second. I'm going to answer my phone. I'm going to have that short conversation. I'm going to put my phone back, and then we're going to continue. It's like the exception is the cell phone that must be answered, rude as that might seem. So this is how we can handle exceptions in Python. And there is a whole long list of exceptions in the Python standard library. If I go here to the Python standard library, if you go down to the bottom of that document, you'll see that there is an exception class hierarchy, because exceptions are objects like everything else in Python. And if they're objects, then they have classes. And the classes here describe the different types of exceptions that can be raised. So here we have index error. And index error, well, it's part of the standard library. It comes with Python, and it's even built in, meaning that you don't need to import anything. But it, along with key error, which is what we get from dictionaries, these are both subclasses of lookup error. So if I'm not sure exactly what kind of object I'm going to have, but I am going to be using square brackets, and I don't know if I'm going to get an index error, key error, I can just trap lookup error, and that traps both of them. You might say, oh, well, let's just trap all exceptions by trapping exception. That's an exceptionally bad idea, because part of the idea of exceptions is that we have this really fine-tuned ability to trap exceptions. We can trap the things that we know what to do when they happen, and we don't trap the things that we don't know what to do. Again, if you don't have a plan, you shouldn't be trapping an exception. Now, there's a very nice, easy thing for me to say as a Python instructor. If you're working on something in production and it's been running for days or weeks and you get an unhandled exception, right? Don't tell your boss that this is because Reuven told you only to trap the exceptions that you have a plan for, right? If you're doing a billion-dollar production set in your Python code and the money and the process depends on you trapping all exceptions, do it, right? But you should have a plan. You should know what you're doing. You shouldn't just randomly, oh, let's always trap everything. I sometimes joke that we can get rid of all problems in Python by putting try at the start of our program, except at the end of our program, and voila, no more errors, right? Yeah. By the way, exceptions, I keep trying to say this, they are not errors. Many of them are errors, but they can just indicate that something unusual has happened. For example, every time you iterate with a for loop, the loop is stopped by a stop iteration exception. And so there are all sorts of things that happen behind the scenes in Python that are handled with exceptions rather than with errors or with other values. Okay, I hope that this was a useful introduction to exceptions. There are many, many more things that we could talk about, how to raise exceptions, how to trap custom exceptions, and so forth. But hopefully this gives you the basics and makes you a little less skeptical that exceptions are a problem. I hope this was useful. If you found it useful, comment. Let me know what you think. I love to hear from people on this channel. You can follow me on Twitter where I have lots of additional Python advice. And of course, there's my free weekly newsletter about Python and software engineering called Better Developers. Sign up at Better Developers Weekly and you'll get new information every Monday. Thanks a lot for watching. I'll be back soon with more information about Python.